We've learned to calculate volume of prisms and pyramids, cylinders and cones, and we've also learned to calculate surface area of all these shapes, with the exception of cones. But we've done cylinders. You learned the formula for that last week. There's the formula. There's a reference for formulas on the assignment, and then other than a cylinder, everything else, every other polyhedron, whether it's a prism or a pyramid, is just made up of polygons by definition. So you find the area of the polygons making up the surface, and you'll have the surface area. In fact, I'm not going to spend the amount of time I normally would reteaching this, because I can tell you've been doing well on this. In other words, I know you know for a problem like one with rectangular prism to label the distinct faces and then draw them and find the area of each and then make your surface area formula. This is what we did yesterday, so I'm not going to look at 1, 2, or 3 with you. I think I'm going to do number 4 with you, but before I even do 4, I just want to mention that problem 5, you did surface area of cylinders last week. You used the formula. We talked about how the lateral area, this term, is the rectangle that unwraps. If you were to unwrap that, like if it was a can of soup, that would be like the label when you unwrap the label. That's 2 pi r h, and then the 2 pi r squared is the area of the two circles that make up the base. So you've got the height and you've got the radius. You have to double check to make sure, is that really radius? But yeah, it's going from center to the edge. If it wasn't, if it was diameter, I would use the diameter to find the radius. But you write that formula. And then you write it again by substituting the values, and then at that point it's okay to use a calculator. I know you know how to do that, so I'm just reminding you that we've done that. This is a lot like this pyramid. I don't think we've done a pyramid, but that's why I'm going to do number 4 with you. So this one's a lot like number 4, which we'll do together here in a minute. Number 7, triangular prism. It's got 2 triangular bases and then 3 rectangular faces, B, C, and D. And you practiced that last week. There's another cylinder, so use the surface area formula for cylinders, but be careful when you're substituting the values to make sure you're substituting the height and the radius. And then this one is another triangular prism, just not shown with the triangles as the top and the bottom, but that's very much like ones we did last week. And this one happens to be the one that I do on the homework help video, so don't forget, you click on today's blog entry and you scroll down to your class period, you'll see there's a video there helping you with number 9. You should try it on your own first. In fact, you don't have to work in order. If you want to try, if after this video, after we do number 4 together, you want to try number 9 and then use the homework help video to double check that you're doing that you're recalling how to do this, that's probably a good strategy. And then maybe do one of the cylinders. And there's a way to check your work as you go, and I'll explain that after we do this one together. So this is a pyramid because it only has one base. It has a rectangle, or more specifically a square, as its base. And so I'll label that face A, and I'll sketch the square. It's an 8-inch by 8-inch square. This triangular face, I'll call that B, and that triangle has a base equal to the side length of the square, 8 inches. And its height, I can tell this is the height because it's shown perpendicular to the base. Its height is 10 inches. And you don't see any dimensions on any of the other triangular faces because, especially since this is a square base, this triangle over here must also have a base of 8 and a height of 10. And interestingly, this height for this triangular face is not the same as the height for the pyramid. The height for the pyramid would be from the apex, from this vertex perpendicular to the square base like this. It would be shorter than 10. But we don't need that height for surface area, but we do need that height for volume. And later this week we'll revisit volume to sort of remind ourselves the difference between finding volume and finding surface area. Okay, so for the surface area, I have the square, the area of square A, base times height or side times side. So 8 times 8, 64. And the area of face B, it's a triangle. This is one of the reasons why you have this reference. So if you're finding the area of a triangle, make sure you use the triangle formula. So look up here for your formulas if you don't have them memorized. I suspect you have most of these memorized, but 1/2 base times height. Then you substitute the dimensions. 1/2 multiplied by the base of this triangle is 8, and the height of this triangle is 10. Half of 8 is 4, and 4 times 10 is 40. So the area of the triangular faces are 40. And we talked a lot last week about every polyhedron has a different surface area formula, just depending on how many faces are congruent. There's only one of those square faces, so there's only one area A, but there are multiple area Bs. Every single one of these triangular faces is congruent. All 4 of them are congruent, so plus 4 times area B to get the total surface area of 64 plus 4 multiplied by 40, or 64 plus 160, for a total surface area of 224. All of the dimensions are given in inches, and even though pyramid certainly is a 3-dimensional object, its surface area is 2-dimensional space, and so that will be inches to the 2nd power inches squared. Now, whichever problem you're doing, even if whether you're doing one of the cylinders, you wrote the formula, you substituted the values, and you used a calculator, you rounded to the nearest whole, and then you're looking. Here's how you can check your work, even though I'm not going over every single one of these on this video. You look down here and you look for the area you found. I find it right away right here. And so the directions are to cross that off. Actually, I'm going to double check myself on those directions. Yeah, cross out the box containing the correct answer you find. Because after you've crossed out 9 of the boxes, after you've done all 9 problems, the boxes that remain will spell out the answer to the riddle. But when you cross them out, just cross them out lightly so you can still see the number in case you want to go back and double check something. But when you're doing one of the harder ones, like a cylinder, for example, if you round it and you don't think you're not seeing your answer down here, go back, scrutinize your formula, the dimensions you chose. Was it really a radius that was shown? That type of thing. Double check the computation on the calculator. If you're not finding it here, then something went wrong, and so that's okay. That's not a bad thing. You just go back and double check your work. And if you're really struggling, the 1 p.m. Zoom is optional, but it feels like more people should be attending than have been. I'm not going to say exactly how many people I saw last week, but I'll tell you it wasn't many. So if that really indicates that nobody is having any trouble at all with 3-dimensional solids and measurement, then that's great news. But if you are struggling, I hope to see you in that Zoom at 1 p.m. so I can help you out. All right, so finish this on your own. You'll be able to tell by whether you're finding your areas here or not, whether you're doing well or struggling. If you're struggling, find me in that Zoom or email me, reach out to me in some way. And then tomorrow we've got a mandatory Zoom, so I'll see you in class. We're going to get started on the next thing together. But I will have a Nearpod for you tomorrow to grade this assignment and to go over any of the ones that you're having trouble with. All right, thanks a lot. Your class dismissed.